Right, this is AP Calculus 2018, the actual free response questions from the test. And we are starting on number 5 of this video. And you do have a little graph of a derivative g prime, but I don't think we're going to use that until we get to part D. So let's start with part A. All right, it says find the average rate of change on the interval 0 to pi. So the average rate of change is the slope of the secant line. So if our interval is from 0 to pi, and it's you've got a less than or equal sign, so you do include the endpoints. To get the slope, that's the change in y over the change in x. So that's f of pi minus f of 0 over pi minus 0. So the denominator's just going to be pi. Okay, f of pi. So f of pi, looks like I need to get a new marker. All right, f of pi is going to be e to the pi. So I'm just plugging in pi up here, times the cosine of pi. Cosine of pi is -1, so that's negative e to the pi. F of 0 would be e to the 0 times the cosine of 0. E to the 0 is 1. Cosine of 0 is also 1, so f of 0 is 1. So f of pi would be e to the minus pi. So the slope is e to the minus e to the pi, minus 1 over pi minus 0, which is pi. And just circle that. You're good to go. So that's the average rate of change between 0 and pi. Don't have to take any derivatives. You're just getting the slope between those 2 points. All right. So part B says, what is the slope of the line tangent to the graph at x equals 3 pi over 2? Okay. Tangent line slope, we've got to get a derivative. So f prime is going to be, of course, this is no calculator section. It's product rule. The first, e to the x times the derivative of the second, so times minus sine x, plus the second cosine x times the derivative of the first, that's just e to the x. All right, so that's just simply going to be plus e to the x cosine x. The second cosine x times derivative of e to the x. So that's f prime of 3 pi over 2 is going to be our slope. So that's e, it's going to be a minus. I'm going to bring that minus there out front. Minus e to the 3 pi over 2 times -1. All right, because the sine of 3 pi over 2 is -1. Okay, so you got to remember your unit circle there. Plus e to the 3 pi over 2 times the cosine of 3 pi over 2. Okay, 3 pi over 2, remember, is straight down. 270 degrees, the cosine would be 0. Negative, negative makes positive, so our slope is equal to e to the 3 pi over 2. And that's all it asks for. We don't have to do a tangent line equation there. Okay, so far so good. I can definitely see the questions on this problem being the types of questions you could get on the 2020 test. Okay, all of these would be fair game. Part C, find the absolute minimum value of f between 0 and 2 pi. So what we have to do is we have to find the critical points, we have to check those, and we have to check the endpoints. Okay, because the interval is less than or equal to, so you use brackets on those endpoints. Okay, so first of all, let's get f of 0. We have to test that. All right, f of 0 is e to the 0, which is 1, times cosine of 0, which is 1, so that's going to be 1. The other endpoint, f of 2 pi, okay, that's going to be e to the 2 pi times the cosine of 2 pi, which is 1, so that's e to the 2 pi. So I've got those two. Now we have to get the critical points. So the derivative, we've already figured out, is equal to minus e to the x times sine x plus e to the x times cosine x. Right? That comes from part B here. We have to set that equal to 0. Well, what you could do is just, let's move this minus e to the sine x to the other side, and we'd have e to the x cosine x is equal to e to the x sine x. Well, the e's are going to cancel out. And you have, where on the unit circle does cosine x equal sine x? Well, you know it occurs at, so our critical points occur at x equals pi over 4. And then that's in the first quadrant, and cosine and sine are the same sign in the third quadrant also, so the other one we have to check is 5 pi over 4. So that's our two critical points. So we have to figure those out. Let's figure out pi over 4. Okay, so we're going to plug that back into the original. That's going to be e to the pi over 4 times root 2 over 2. Okay, cosine of pi over 4 is root 2 over 2. So that'll be root 2 over 2 times e to the pi over 4. And then let's take a look at 5 pi over 4. Okay, well, cosine is going to be 5 pi over 4 negative root 2 over 2. So that's going to be negative root 2 over 2 times e to the 5 pi over 4. That's the only negative one. So the absolute min is going to be negative root 2 over 2 times e to the 5 pi over 4. That's the only negative one. And when you have a closed interval, okay, brackets, when it's on the problem, it says, you know, your interval is less than or equal to, okay, in this case, I guess 2 pi. All right, we have to check the endpoints. If you didn't have that, you wouldn't have to check the endpoints. The endpoints aren't part of it, but you do have that, so it's a closed interval. Okay, so go ahead and pause if you need to keep writing down. I'm going to erase. So part D is we want to take the, it says g, let g be a differential function so that g of pi over 2 is equal to 0. The graph of g prime, the derivative of g, is shown below. Find the value of the limit as x approaches pi over 2 of f of x over g of x. This is a case where you want to use L'Hopital's rule. L'Hopital. All right, you want to use L'Hopital's rule because you're going to end up using g prime, which we can get that value from the graph over here. So to use that, we'd have the limit as x approaches pi over 2, and you take the derivative of the top and the bottom. Okay, so f prime of x, we've already said, is minus, from part B, minus e to the x sine x plus e to the x cosine x. Now on the bottom, if we take g prime of pi over 2, okay, g prime of pi over 2, we can find that right from the graph. It's 2. All right. right? So if you plug in pi over 2 to g prime, which is what we're doing here, we're taking the derivative, then it's 2. So let's plug in pi over 2 to the numerator. So that's minus e to the pi over 2 times the sine of pi over 2, which is 1, plus e to the pi over 2 times the cosine of pi over 2, which is 0. So that's going to be minus e to the pi over 2 over what? 2. So there you go. It's much easier to deal with this if you take, if you use L'Hopital's rule, take the derivative of the top and the bottom and then plug them in, and it's pretty easy on this one. You just have to read the graph. So there you go. That's number 5. Definitely a good problem to study for the 2020 test. Make an asterisk on your notes so you come back to that one. All right, number 6. Now number 6, you get a differential equation, dy dx is equal to 1/3 times x times y minus 2 all squared. So we'll be coming back to that. The first one says sketch the slope field that goes 0 to 2, or x equals 0, y equals 2, and the one that passes through the point 1, 0. So x equals 1, y equals 0. So what you want to do is just, so for the one at 0, 2, that's just a straight line right there. Just follow the dashes. And then you're starting at 1, 0. That starts here. You want to just follow that contour around. So it takes a little bit of art skill. I hope that you can see that. Okay. Right. I'm not sure if you can or not, but try that yourself. Try sketching that out. Could you have something like that on this year's test? I don't know. I think you might have to read a slope field, but I'm not so sure you're going to have the ability to draw one. But I do think you might have to interpret a slope field. Okay, part B says let y equals f of x be a particular solution. We have the initial condition f of 1 is equal to 0. Write an equation for the line tangent. Okay, we've already got the derivative right there. Already got it. Let's get the slope. So we've already got our point. X equals 1, y equals 0. So it's 1/3 times 1 times 0 minus 2 all squared. So that's 1/3 times negative 2 squared, which would be 4. So 4/3. All right, so we have y minus y1, which is 0, is equal to 4/3 times x minus 1. There's your tangent line equation. If you want to clean it up, you would just have y is equal to 4/3 times x minus 1, but you don't have to. Circle that. On the 2020 test, maybe you snap a picture of that. And then we want to use that equation to approximate f of 0.7. Well, all you're going to do is plug 0.7 in for x. So that's 4/3 times 0.7 minus 1. So that's 4/3, sorry about that, times negative 0.3. That's negative 1.2 over 3. If you want, you could just leave it like that. But that reduces, if you want, to negative 0.4. But if you're not sure about that, what the heck, just circle that. Circle that. Don't make them count off for you not reducing, which I don't think they will do. Okay, I might need a little bit more room for part C, so pause if you need to. And part C is the classic find the particular solution. So differential equation. I believe this is fair game on the 2020 test. So Got to be ready to do this one. So we're going to separate those variables. I'm going to bring the y minus 2 squared underneath dy. And I'm going to multiply both sides by dx. We've got 1/3 x dx. So we're going to integrate that. Dy over y minus 2 all squared is equal to 1/3, bring that 1/3 out front, x dx. Okay, this is the same as y minus 2 to the minus 2. And that'd be 1/2 x squared. Integrating that times 1/3 would be 1/6 x squared plus c. So this side, you could do a u substitution if you wanted. I think you could probably figure that out, though, that the y minus 2 needs to go to the minus 1. And then you need a minus out front. And then if you take the derivative of that, you can see you get back to y minus 2 to the minus 2. So this is going to be minus 1 over y minus 2. I'm taking this to the negative 1 and bringing it down, is equal to 1/6 x squared plus c. All right, our initial condition was f of 1 is equal to 0. So now we can plug in 0 for y, so that's going to be negative 1 over negative 2 is equal to 1/6 times 1 squared plus c. So that's 1/2 is equal to 1/6 plus c. All right, so that'd be 3/6. So c is going to be 2/6, which is 1/3. So plugging that back in, I would have minus 1 over y minus 2 is equal to 1/6 x squared plus 1/3. On the 2020 test, I would probably snap a picture of that and say that's the answer. But who knows? One thing you could do, you could solving for y, let's bring that 1/6 x squared plus 1/3 underneath. So we've got negative 1 over y minus 2. Excuse me. Negative 1 over 1/6 x squared plus 1/3 is equal to y minus 2. So I took the y minus 2, brought it up top over here, and brought the 1/6 x squared plus 1/3 underneath. So negative 1 over 1/6 x squared plus 1/3 plus 2 is equal to y. And one way that you could improve this is just multiply this fraction by 6/6, right? It's the same thing. So that's going to be negative 6 over, because that would clear all these fractions on the bottom, over x squared plus 2 plus 2, and you don't have to do the 6/6 times that, it's just going to reduce back to 2, is equal to y. Don't know if that's worth the time to do, especially in the 2020 special year. You might want to just stop right here. Even if they don't give you that, you're going to get a lot of partial credit along the way for separating the variables, for getting C. This final step to get from here to here is probably only going to be worth 1 point out of probably a 5-point problem, so I wouldn't worry about it too much. So that concludes the actual 2018 test. I did have a student make a 4 on this test, so definitely a doable test overall. So I will see you, not see you, but I will talk to you next video.